Now let's talk about the mock 3 question 4a. A sales manager would like to compare a recent performance of 2 salespersons under his supervision. From the sales record, their daily sales were normally distributed with the same mean and the standard deviation were $200 and $215. Amount of sales of 10 days in the sales record will be selected randomly. For each salesperson, calculate the probability that their mean daily sales will have a difference of at least $150. Therefore, the difference of means is applied, and because the samples are large and the sigma of 2 salespersons are known, the z-table is used in this question.
To find out the probability, let mean x1 be the mean of the daily sales of the first salesperson, and let mean x2 be the mean of the daily sales of the second salesperson. Assume the random samples are drawn with replacement or infinite population. The difference of the mean daily sales between the two salespersons will be mean x1 minus mean x2, which is under normal distribution. The difference of mean is 0, and the mean variance will be 200 squared plus 250 squared over 10. To find out the probability that their mean daily sales will have a difference of at least $150, the probability should include the two parts, which is the difference less than negative 150 and larger than positive 150. The two parts will be in the same area, so 2 times the probability of set value larger than 1.48, and after the calculation, the probability is 0.1388.
Now I will talk about the mock 3 question 4b. In evaluating a customer satisfaction level, a company would like to be 95% confident that error in estimating the population mean does not exceed 0.05, and the population standard deviation is given, which equals to 0.8, and the sample size is required. When we solve these kind of questions, we always assume that the sample size is large. Therefore, in this question, the z-table is used. First, we need to make the following assumptions. Let n be the sample size required. Let x be the customer satisfaction level. Assume the random samples are drawn with replacement or infinite population. Assume x follows normal distribution with a mean of mu and a standard deviation of sigma. Based on the information given by the question, sigma equals to the population standard deviation, which equals to 0.8, and alpha equals to 1 minus confidence level, which equals to 1 minus 35% and equals to 5%. So a 95% confidence interval for the customer satisfaction level could be calculated by the following formulas. And we know that alpha equals to 5% and sigma equals to 0.8. So after calculation, we could know that n is bigger than 983.4496. And the n represented the sample size, and the sample size must be an integer. So the sample size required is at least 984.
Let's talk about Mod 3. Question 4c. In a random sample of 500 clerical employees from a large multinational company, 300 said they would like the company to adopt a feasible scheduling policy, which will permit employees to decide when and how much they will work. Contract a 90% confidence interval to estimate the population proportion of clerical employees favoring the flexible scheduling policy. Explain briefly how the confidence interval should be interpreted. Let P be the proportion of clerical employees favoring the feasible scheduling policy. Assume the random samples are drawn with replacement or infinite populations. A 90% confidence interval for clerical employees favoring the feasible scheduling policy is these equations. Lastly, The answer is 0.5640 to 0.6360.
I'm Pauline and I will talk about paper Mod 4, question 4, part A. The question is, in a study of turnover rate of new employees after a 1-year period, 150 new employees from various departments are selected randomly, and 29 of them are no longer employed after the 1-year period. Construct a 98% confidence interval for the turnover rate.
Hello everyone, let me talk about the mod 2 question 1, and then this talking about the financial analysis or in the interested percentage of the revenue spent by the company, software companies, computer software companies on the R&D. And then here is the random sample size draw with the computer software companies. And then here is already the figure summarized of the 15 total number, and then we will use that figure to calculate the following mean and standard deviation. Okay, we will use the previous table to calculate the class boundary shown here, and then we will have the class mark from the class boundary. After calculation, it means each of the class mark is 5.7, 6.9, 7.9 something, 0.8 something. 0.8 in here is 7.9, and then we will use the class mark by the frequency as the numerator of when we need to calculation the mean, and then here is the n, it means 50. Here the 50 is come from the summations of all of the frequency, and then the numerator divided by the numerator, we will have the sample mean, which is 8.362%. And then we will use this figure to help us to calculation the standard deviation of that sample, and then the sample standard deviation. Here is the formula come from the textbook page 23, and then we will apply those of different figure in this table already, and then such as n refer to 50, and then the summations of fx is here, it means the numerator of mean, and then we will divide it by the 50 by the 50 minus 1, and then after all of them it have been divided, we will use the square root, and then after the square root of the figure, we will have the sample standard deviation of 1.7370%. And then now we will talk about how to calculation the following figure. First of all, we also need to use the sample mean x bar, and then the sample standard deviation mean s in here. And then as I told you before that the n is larger than 15, they mean we can use the set table, because the set table need to use when we need to do it is know the sigma, and then the larger sample, and then we can have a following assumptions, such as assume that the random sample is drawn with the replacement or the infinitive population, and then we assume that the x is followed the normal distribution, and then here is the population mean, and then here is the population variance. We also assume that the population mean is equal to population's standard deviation is equal to the sample standard deviation, it means 0.8, and then approximately the alpha is can be the total, that means 100% minus 99%, that means we have 1%, and then 1% divided by 2, and then we check the table of set, we will have the figure of 2.56 of 2.576, and then we apply the sample standard deviation, no, sample mean, and then as I talk about, the x bar will be here, and then after apply the formula we will get the answer of different two figure, and then we will know the range of the 99% confidence interval of the population mean will fall in this range. Thank you.